Hello again, it's Mr. Donahue. This time we're going to take a look at sigfigs in rounding. So, we're going to find out why your calculator is a liar today. So, objectives: learn how math is done in science, including how to round and dealing with numbers of various precision. And that's it. We're going to talk about rounding essentially, all right? So, strap into your seats. So, a little quick review of sig figs. Remember that all of the numbers that are important are sig figs. So they're important when we measure them or estimated them directly. So 0.0025 centimeters would be 2 sig figs because these zeros are placeholders. We didn't measure anything for them, but we measured and estimated the 2 and the 5. 12.5 milliliters would be 3 sig figs, and 450 grams without a decimal point would only be 2 sig figs. So if you can look at those and go, yeah, I know exactly how many sig figs they are. Awesome. If not, maybe rewatch that video because we're going to need to have that skill down pat before we talk about rounding. All right, so what's 12 milliliters plus 0.05 milliliters, huh? Well, your calculator would have you believe that it's 12.05 milliliters, and it's lying to you. It's wrong. That's not right, and we're going to talk about why. All right, so there's uncertainty in measuring. No measurements are exact. We can't measure exactly. We can measure precisely, but there's always some uncertainty. So, for example, this 12 is really 12 point, who knows what's in those place values? We don't know. So there's a certain degree of uncertainty with all of our measurements. So we can only be as precise as our least precise measurement. So what I'm saying is, well, if I had 12 and I added 0.05 to it, well, do I know what is in the hundredths place for that 12? No. What's question mark plus 5? Who knows? What's question mark plus 0? I don't know. And then 2 plus, then we'd have 12 point who knows what. So we can't be more precise than our least precise number. So if we're taking a look at this, you can think of it kind of like links in a chain. So the calculator would have you believe that when you did all this math, that the answer was 1,172.008. But a chain is only as strong as its weakest link. So if I'm taking a look here, this value is only precise to the hundredths place. These numbers are more precise and we know more digits, but our least precise number is this 1100 because we don't know what's actually in that tens place or in that ones place. So our answer is only going to be able to be precise to the hundredths place. So the least precise number in our math is the weakest link in the chain, and that's the one that we're the most interested in when we're talking about rounding from our calculator. So how do we maintain the integrity of our math? Well, if 12 milliliters and 0.05 milliliters doesn't equal 12.05 milliliters, then what does it equal, Mr. Donahue? What does it equal then, huh? Well, we need to round our calculator answer and always err on the side of being conservative. It's like we're being afraid of being wrong, right? Because we don't want to be wrong. We want to be only as precise as we can be. So for addition and subtraction, you got to find the least precise number in all of your math, and you need to round your answer to that place. So for example, if I had 12 milliliters plus 0.05 milliliters, well, my calculator would give me this answer. But now I got to look at the numbers that I was working with. This number is only precise to the ones place, and this number is precise to the hundredths place. So I got to find the least precise number. So that tells me that I got to round to the ones place. So I look 12.05, the ones place is at 2. I look one place over, it's a 0, and that 2 is going to stay a 2. So I'm going to get just 12 milliliters. That's what it is. But wait, we added stuff to it. How do you get the same answer? Think of it this way. It's like, how much water is in the ocean? And then, well, how much water is in the ocean if I added an eyedropper worth of water to it? You're going to ignore that. It's so little compared to the rest of it. Okay? So let's take a look at this answer, or this problem. Again, I have all these numbers. I get this number in my calculator, which is right here. And now I got to round it. So I got to look at all these numbers. So this is the thousandths place, tenths place, ones place, hundredths. So the hundredths place is my least precise measurement. So that means I need to round this answer to the hundredths place. So I'm going to look at what's going on in the hundredths place. It's a 1. I look one place over, it's a 7. It's greater than 5. So I'm going to round up to 2. So I get 1,200. Don't stop here. Don't go, all right, well, it rounds to 12 and all these disappear. You need to put placeholder zeros, right? Don't round 1,172 to 12. That's silly, all right? It's 1,200. All right, so multiplication and division, we got to do something a little bit differently. We're going to look at sig figs instead of precision. So we got to find the number with the least sig figs. So then you need to round your answer to that many significant figures. So, for example, if I had 12 times 12, that's giving me 144. And I got to count my sig figs. I got 2 sig figs and 2 sig figs, so my answer needs to have 2 sig figs. So I count from the leftward side. So I'm going to count from the leftward side. That means this 1 is my first sig fig. That 4 is going to be my second sig fig. I look over, it's a 4. My 4 in the tens place is going to stay a 4. So I get 140. So that's how that's going to work. All right, let's take a look at another example. If I had 152 divided by 26, I'm going to get this super irrational number going on, blah, 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 blah. So I got to look at my numbers. I got 152, which tells me I have 3 sig figs, and 26 has 2 sig figs. So I need to round this answer to 2 sig figs. So I count from the leftward side. So I got a 5, 8. So 1, 2, that's my second sig fig. I look over, it's a 4. That 8 is going to stay 8. I'm going to get 5.8. Okay? Not super terrible. But what if there's a problem that has addition, subtraction, and multiplication and division? Then what do we do? Well, you follow your order of operations first, and you only round off at the end. You should only round once, right? So round once, don't round multiple times. But keep track of how it would have been rounded for each step in your operation. I'll show you what I'm talking about. So let's say I had this number. I got 12.45 plus 2.0 times 1.891. Well, first, your PEMDAS. Do your parentheses. I get 14.45 in my parentheses, but how would I round that if I'm adding? Well, it would have been rounded to 14.5 because, hundredths place or tenths place. So I'm going to have to go to the tenths place. That would have rounded to 14.5. So that has 3 significant figures. So I know that this, in parentheses, totals 3 sig figs. I'm not going to use 14.5. I'm going to use my unrounded answer for the rest of my math, but I'm going to remember that this is actually going to be 3 sig figs. So then you continue your operations using your unrounded value. Use your unrounded value, but keep track of how many sig figs it should have. So then I do 14.45 times 1.891, and I get this answer in my calculator. So now I got to figure out how I'm going to round my final answer. So the parentheses should only have 3 sig figs, and 1.894 has 4 sig figs. So I need to round my answer to the fewest number of sig figs, which is 3. So then I'm going to go, all right, well, first, second, third sig fig, look over, it's a 2, and then I'm going to keep the 3 at 3. I get 27.3. There you go. That's it. All right, so wait, why do we wait until the end to round? Why can't we round in between? Well, rounding once is better than rounding multiple times. So each time you round, you're dropping numbers, and that's going to mess up your math. So, for example, if we, rounded, our final answer rounding at each step is 27.4, but if we round just at the end, we get 27.3. So we end up with a different number, and we only had rounding once in between. If I had a really long problem with more steps and you rounded at each step, you're going to have a much greater effect, and that's going to, throw off your answers. You don't want to do that. So let's do some practice, right? So again, I'm going to throw these up, and you guys pause the video, try your best, do the math, check, see how you do, and then press play, and I'll walk you through it. All right? All right, cool. Welcome back. So we got 30 divided by 40. Well, we got 1 sig fig and 1 sig fig. So when I do my math, the calculator is going to tell me I get 0.75, but I got to round it to 1 sig fig. So I look in the tenths place, and I look one place over, it's a 5, so that 7 is going to round up. I'm going to get 0.80. Or, I'm sorry, nope, just 0.8, 1 sig fig. That is my final answer. Whereas if I had 30 with a decimal point and 40 with a decimal point, that's telling me I got 2 sig figs and then 2 sig figs in that number. So I'm going to multiply them, and I'm going to get 1,200. And I got to keep 2 sig figs, which means I got 2 sig figs right here. And there we go, 1,200 without a decimal point, because that is 2 significant figures. All right, 12.45 minus 12.4, and my calculator is going to tell me I get 0.05, but this is a addition and subtraction problem, so I got to round to my least precise number. So this is to the hundredths place, and this is to the tenths place, so I got to round my number to the tenths place. I look in my tenths place, I look one place over, It's a 5, so that 0 is going to round up. I'm going to get 0.1 as my answer. All right, 15 plus 120. The calculator is going to tell me I get 135, and I'm going to have to look at my numbers now. The least precise one, let's see, this is precise to the ones place. This is precise to the tens place, so I'm going to have to round to the tens place. So I look at my 3 in the tens place. I look over, there's a 5 there, so it's going to round up. I get 140 without a decimal point, and that is my answer for that one. All right, so for this one, I got multiple steps. I got to do what's in the parentheses first. So I get 25.47, and how would I round that? Well, it's the hundredths place here and the hundredths place here. So I look at my hundredths place, and I'm just, there I go. There, I don't have to round. There's no number after it, so I know it's going to stay a 7. So that is my number, and it has 4 significant figures. And then I do my division, divided by 16.0, and I get 1.591.875, and it probably keeps on going forever. So now I got to look. Well, I got 4 sig figs in my parentheses answer, and I got 3 sig figs in my 16. So I'm going to have to round to 3 sig figs. So count from the leftward side. 1, 2, 3. So that 9 is my last significant figure. I'll look over. There's a 1. So it's going to stay a 9, and I got 1.59 as my answer for that one. All right, one more. So I get 19.0 divided by 9.0 plus 14.85. So order of operations, do the parentheses first. So I'm going to get 2, and if I'm doing a division, I need to look at sig figs. 18 has 3 sig figs, and the 9 has 2 sig figs. So I'm going to have to round my 2 to 2 sig figs. Well, how do I show 2 with 2 sig figs? I'm going to have to do 2.0. That's how you do that. All right, so I got 2.0 plus 14.85, which is going to give me 16.85. Now, how am I going to round this? Well, my 2.0 is going to be to my tenths place, and my 14.85 is in the hundredths place. Because I'm doing addition, I got to look at the precision. I got to round to the least precise, which is the tenths place. So I look in the tenths place value. I look one over. There's 5, so that 8 is going to round up to 16.9 as my final answer. All right. So yeah, summarize. How are you supposed to account for uncertainty in measurements? How are you supposed to round with addition and subtraction? How are you supposed to round multiplication and division? So that's what this video was all about. I hope you can summarize those things, and I hope you learned something. I'll see you in class. Okay, bye.